My dear students, greetings of the day. As you know that the entire world and the country is facing corona pandemic, COVID-19. In this situation, you know that the university and educational institutions has been closed till April 14th, 2020. In this situation, the education of the students does not suffer, so the university has made the plan that we can continue disseminating the information through online mode. So I'm just trying today the first recording on the YouTube, and that I will be uploading soon, so that all my dear students can get apprised about some of the concepts of today's topic which we are going to discuss. As you know that in the first unit we have discussed about the fundamentals of remote sensing, aerial photography, and how we prepare the maps by using the aerial photography and remote sensing. As we know that we can prepare a number of maps from the remote sensing and aerial photographs. So those maps are to be used for the natural resources mapping and management purpose. So how those maps can be used? For that we use an information system that is known as geographical information system, right? So today I will be apprising you about what do we mean by geographical information system, what are the different components of the geographic information system, and why the geographic information system is so powerful. As you know that when we talk about the GIS deals with the geographic entities. And when we are talking about the geographic entities, we can say that we are talking about the point, line, or polygon. So when we want to deal with this type of the data, then how we are going to tackle, or it may be even the grid form, which we'll be discussing, that what can be the different type of the data in the GIS. So to begin with, what do we understand by the GIS? As you know that when we are talking about the GIS, we say that GIS is nothing but it is the geographical information system, means that we are going to understand the GIS in the form that whatever entities are available to us, we want to analyze those for better planning and management purpose. And in layman's language, we can define GIS as computerized maps with lot of associated data and analysis capability. So we will be dealing with a number of maps for the analysis purpose. As we can take an example that when we are talking about the preparation of maps by using the remote sensing and aerial photography, then we are talking about that we have prepared, say, land use land cover map, we have prepared groundwater prospects map, we have prepared soil map, we have prepared soil types map, we have prepared land use land cover map, we have prepared slope map. So now I want to analyze all these maps together. So if I'm dealing with one map only, it may be possible that I can identify that what are the different features which are available in a particular area. But when I'm talking about a number of maps and I want to analyze these together, so it will be very difficult to do it manually. So what we do, that we first digitize the computerization of maps. The process is known as digitization. So we digitize all these maps and put into the computer by taking the features and also the associated data. For example, we have digitized a polygon. So this polygon is a water body, or it is a particular landform, or it is say grassland. So we have to think in that terms. Once we have digitized, we have input all this data into the GIS, then we use different formats to make the topology, to see the data, how it is associated. So when I'm dealing with a number of maps together, then it will be easier for me to analyze these in the computers. In other words, we can say that GIS is nothing but it is the computerization or computerized information management system. So when we are talking about computerized information management system, it is having the capabilities. It is having the capabilities to not only collect, store, analyze, and retrieve information based on its spatial location or relationship, or identify location within a targeted environment which meet specific criteria. So when we are talking about that, we can input whatever outputs are there from the remote sensing that will be acting as the input into the GIS. All these thematic maps, all different maps which are theme based, which we have prepared, these will be acting as the input into the GIS. And then we will be making some queries. Those queries may be simple, what lies here, where lies this, or complex, that we are talking from one map class 1, from second map class 1, from third map class 3, from fourth map class 4, like this. And we want to identify that which is the area which meets these criteria. For example, it will be easy to understand with a small example. Nowadays you see that we are having lot of problems related to solid waste management. So I am taking an example of, say, Kurukshetra city, which is of small or medium city. So if I want to identify a location from the periphery of Kurukshetra city, so what is the characteristics which that area should meet? So the first characteristic we can identify that it should not be more than 5 kilometers from the periphery of the city. So we are having the urban boundary. From the urban boundary we have taken a political map which is showing the roads, railway line and the locations, and we will be identifying that any area which is in the range of, say, 2.5 to 5 kilometers. And then the second map can be land use, land cover. So as you know that we will always be avoiding the areas which are agriculturally fertile or which is having a good agricultural land. So we will always try to find out the area which is a wasteland. So in the second category we have given a class that it should be a wasteland, and then we can say that the wasteland should have minimum of this much size looking to the size of the city. And then we are having the slope map. As you know that Kurukshetra is a plain land, otherwise in the hilly areas we have to identify that the area should not have the steep slope, otherwise the cost of transportation will increase. Then number 4th can be the soil type. Why we are interested to understand the soil type in this area? Because if the soil is sandy or it is sandy loam, then the leaching of the leachates from the solid waste ground will be easier into the groundwater. So we will always try to identify the areas which are having clay type of the soil or which is having less porosity, rather less permeability, right? So we will try to identify those areas. And then number 5th can be that I am having a map which is depth to groundwater. So groundwater level should not be near to the surface, it should be moderate to steep, means it should be at least 15 to 20 or 30 meters depending on the location and the area. So now we are having all these maps. Now after preparing and digitizing all these maps into the GIS, and then I have given a query that from class 1 I am having a limitation that the area should lie between 2.5 to 5 kilometers, and number 2, land use, land cover, it should be preferably wasteland, so area may be, for example, more than 5 hectares. And number 3 I have taken about the slope, it should be gentle or it should be gentle. And when I'm talking about, say, depth to water level, it should be moderate or deep, say more than 15 meters. And when I'm talking about the soil, it should be the clay type of the soil which is having very less permeability. Now the GIS will analyze these complex query and give us a location that this is the location which meets the specific criteria, right? So that is how the GIS is going to help us. When we are having all these maps in the manual form, then it may be, after overlaying one over the other manually, we can identify for one location. But when I'm analyzing for the entire district or entire area, it will be very, very difficult to do it manually. So now we can understand that when we are talking about the GIS is nothing but we are talking about the computerization of information or the maps which is available with us. And those maps are having lot of associated data, which we also call it as the attributes. So all those data are also associated when we are digitizing it. And after that we have put a number of layers. All these thematic maps we call in GIS as the layers, right? So we will be saving this in the form of the layers in the GIS, and then we can give the simple or the complex query to understand that very simple queries like where lies this, or in other words we can say that an area we want to identify which is having a number of parameters which we can understand or we can know. So when we are talking about this, we can say in other words that GIS is nothing but it is the a very, very powerful tool which helps us in not only identifying but also understanding that what it is available for. So it is computer based So all the power and benefit of the computer technology are available, like very flexible input and output, large and efficient data storage and retrieval, and we are having very high analysis capability, and we are having very good communication and data sharing capability. So what do I mean by very flexible input and output? So when I'm talking about the input, so we may have the data which is available to us either in the form of the maps or from any other agency in the form of a soft copy. So we can use the input, that is for example the keyboard, we can have the scanner, we can have the digitizer, we can put the data into the computer, then we can prepare the outputs whatever we desire, a particular class output or a map output. Large and efficient data storage. If we want to manually store the data, you can say that we are dealing with lot of maps which are having a lot of space. So it is very difficult. Once we have created the data and put into the GIS, you can have the primary or the secondary devices, and it is very easy to store the data. And when we have prepared all these maps in the GIS, all these maps helps us in analysis. Means we can use those maps which have been put into the computer. Then we will be going for analyzing by using complex queries, and then once we have prepared the outputs, then it is very easy because we will be using the information and communication tools to go for analyzing all this information which will be available to us. So that way we will be going to use the GIS. So when we are talking about the GIS, we say that GIS is having a number of components, and to begin with, we can say that GIS is having 5 major components. The first one is the hardware, second one is the software, third is the data, fourth is the people, and fifth is the methods, right? So these are 5 major components which GIS is having. So when I'm talking about the hardware, we will be talking about that when we are using the GIS, what are the different hardware requirements. For example, we need a PC with peripheral devices. Peripheral, we need some devices for the input, we need some devices for the output. Software, a set of instructions that makes GIS, because GIS deals with the maps. So those maps, we call it as the data. So what will be the data, what type of data will be available to us, and then where we require the people and the methods. So we will be discussing these one by one. So first we will be going to the hardware. So when I'm talking about the hardware is we need a computer or a laptop with sufficient memory or sufficient storage space, because you will be dealing with a lot of data, so you have to have the analysis capability. So it should be a good memory, RAM and ROM, which will be available with the computer, and then the graphic input and output devices. So in the input we can use the digitizer or large format scanner. So we are simply scanning the device and using it in the display unit, so we can input the features, or we can use the large format scanner. Right, large format scanner, we are having big maps like the topo sheets, A0 size, so we can directly scan and put it. Plotters, for the output we need a printer or the plotter. Plotter is nothing but it is the large format printer, and when we are using some sort of server based systems, then we also require the network, right? So all these things we require when we are going for the hardware. So when in the hardware, you can see in the present slide that we are talking about the digitizing table. You are seeing on the left hand side on the top that we are putting the map, pasting the map into it. We are using a mouse, and then we are going ahead with digitizing different features, whether it is a point, it is a line, or it is a polygon, and then we require the scanner. In other words, we can use not the digitizing table, but we can use the scanner, just scan and put it on the visual display unit to digitize it, and then we are having certain things for the storage, that may be primary or the secondary, and then we are having the output. We can have the printer or we can have the plotter, as you see in the image. So the second component of GIS is that we are talking about the software. So when we're talking about the software is, as you know, that it provides us the functions and tools to input, edit, store, analyze, and display, retrieve geographic information. For example, in the market, we are having a lot of softwares available. ArcGIS is one type of software, Map Info, AutoCAD, automated computer aided designs. We are having GRASS, we are having ILVIS, we are having a number of softwares which are available. So these are required so that we can input the maps in the desired format. Or when we are talking about putting the maps in the desired format, so those maps which we are going to input into the computer, that is nothing but we say that it is a data. So the data may be in the form of maps, or the data may be in the form of the attributes or the tabular form, which we'll be discussing a little bit later. So all these maps are acting as the data. So when we are inputting the data, there is a famous saying in the computer terminology that GIGA, garbage in, garbage out, right? So input here is we are putting the data. So we have to be very sure that our input data is accurate. Then only we will be saying that our input data is also accurate. So when we are talking about the data, we should be sure about what is the source of the data, what is the scale of the data, what is the accuracy of the data, and what is the date of creation, right? So if we are having the maps which are having the dynamicity, for example, land use land cover map, that may change after a year or after 2 years or after 5 years. So we have to sure about that land use land cover is of which year, right? And then accuracy, we have to be very sure. Otherwise, the locational as well as the positional accuracy, we will not be able to say anything on what is the scale of the data and what is the source of the data, primary, secondary, which agency has prepared this data, and all those things. So when we talk about the data, we can have data in three forms. One is the vector data, as I was discussing since beginning, that we can have the vector data in the form of the point, line, or polygon. So if we are having a data which is in the form of the point, line, and polygon, we call it as the vector data. Raster data, the data which is in the form of the grids or continuous data, for example, the satellite image. So we are having the data in the form of the pixels which are arranged in a particular row and column fashion. And the third, we call it as the attribute data, or also we call it as the tabular data. So this is nothing but it describes the characteristics of the vector or the raster data. So these are the three, you can say, different type of the data source. In this image, in this slide, you can see that we are having the data which is spatial data or non-spatial data. So when we are talking about the data which is locational data or the vector data, we are having the data in the form of the point, line, and polygon. When we are talking about the raster data, we are having it in the form of the grid. And when we are talking about the tabular data, it is nothing but it is a non-locational, or we can say it is a description. So for example, we are having a soil map. So what are the different classes, what are the values we have given, and what are the different values it denotes. For example, 1.1 it is a fine sand, and 1.2 it is a coarse sand. And again, which we were talking about the dynamicity or the year of creation. So T1 and T2 is nothing but it is the temporal. Temporal means in which year the data has been created. So these are you can say the details about when we are talking about the data. When we talk about the data in the GIS, right? So the data can be the base maps. We have prepared a very preliminary information as we have discussed in the remote sensing. We can have the business maps that may be dealing with the census, consumer products, financial services, etc. That may be the environmental maps, for example, environment, weather, topography, natural resources, pollution sources, or general reference map. So all these in the form of the map or in the form of the data can act as input into the GIS. So the third very important component of the GIS, we say that it is the people. As you know that when we are talking about the GIS, it is nothing that but it requires people at all the places, right? So the three previous components was hardware, software, data, and fourth one is people. So we require people right from the developer of the software to the user, the person who is inputting or digitizing the data. So we require the GIS professionals at various levels: GIS database and data model design, GIS application design, the person who is designing application for a particular you can say use, and then GIS database manager or administrator. We are talking about GIS database creator, operator, or the GIS based data users. So as we can say that we require the people, right from the person who has created the software, then designed different tools, to the very basic level where the people are inputting the data into the GIS. So we require the people at different levels. And the next is the methods. As you know that whenever we are using a particular tool, right, you must have certain guidelines, you must have certain specifications, certain standards are to be met, certain procedures are to be followed. So when we are talking about the methods is nothing but it is a combination of all these four components: guidelines, specifications, standards, and procedures. So when we adhere to these, this is very, very important for the accuracy of the outputs. So whatever derivative maps we will be preparing by using the data which is available to us, if we have not adhered to the guidelines which have been given by the sponsoring agency or which are required by the user agency, so we will not be able to really use it. It's specification, so how much accuracy we require, what should be the error which we can accept, and what are the different standards we have to make. So these are all things which we have to keep in the mind when we are talking about the methods. So in nutshell, if I would like to say that when I'm talking about the GIS is nothing but it is a combination of these five components: hardware, software, data, people, and methods, right? So the people, we also at times call it as the humanware, right? So humanware, I mean, we are using the human beings at different places, so that's why we are talking it as the humanware. So how GIS works? As you can understand by now that when we are talking about the GIS is nothing but we are talking about that we are using it for the analysis purpose. We are having a complex data which is available to us. That complex data is to be used not only for the purpose of analysis, but also we are preparing a number of derivative maps, right? So derivative maps can be used by the line agency. So this is in nutshell the GIS, that how we define the GIS and what GIS can do. Why GIS is so powerful? GIS is powerful because computer is powerful. GIS is based on the computers, and computer is having the lot of analysis capabilities, lot of visualization capabilities. So all these are available to the GIS also. So because computer is powerful, so is the GIS. GIS can deal with a number of complex data, and we can come out with the different models which we will talking in the next class. So for today, I think we will stop here and we will talk the more in the next class. Thank you very much.